program. This JavaScript program will take up multiple lines. To type the program into the console, you'll have to add new lines by pressing Shift-Enter at the end of each line. If you just press Enter, Chrome will try to execute what you've written, and the program won't work as expected. I warned you that computers were dumb. Type this into your browser console. // draw as many cats as you want. Var draw cats equals function how many times. For var I equals 0, I. Console.log eyes closed smiley. Draw cats 10, // you can put any number here instead of 10. At the very end, press Enter instead of Shift-Enter. When you do that, you should see the following output. 0 eyes closed smiley. 1 eyes closed smiley. 2 eyes closed smiley. 3 eyes closed smiley. 4 eyes closed smiley. 5 eyes closed smiley. 6 eyes closed smiley. 7 eyes closed smiley. 8 eyes closed smiley. 9 eyes closed smiley. If you made any typos, your output might look very different or you might get an error. That's what I mean when I say computers are dumb. Even a simple piece of code must be perfect for a computer to understand what you want it to do. I won't go through exactly how this code works for now. We'll return to this program in Chapter 8, but let's look at some of the features of this program and of JavaScript programs in general. Signs, and a few words that might seem mysterious at first, like var and console.log. These are all part of JavaScript's syntax, that is, JavaScript's rules for how to combine symbols and words to create working programs. When you're learning a new programming language, one of the trickiest parts is getting used to the rules for how to write different kinds of instructions to the computer. When you're first starting out, it's easy to forget when to include parentheses, or to mix up the order in which you need to include certain values. But as you practice, you'll start to get the hang of it. In this book, we'll go slow and steady, introducing new syntax little by little so that you can build increasingly powerful programs. // draw as many cats as you want. This is called a comment. Programmers use comments to make it easier for other programmers to read and understand their code. The computer ignores comments completely. Comments in JavaScript start with 2 // Everything following the slashes on the same line is ignored by the JavaScript interpreter. So the comments don't have any effect on how a program is executed, they are just there to provide a description. In the code in this book, you'll see comments that describe what's happening in the code. As you write your own code, add your own comments. Then when you look at your code later, your comments will remind you how the code works and what's happening in each step. There's another code comment on the last line of our program. Remember, everything after that // isn't run by the computer. Draw cats 10, // you can put any number here instead of 10. Code comments can be on their own line, or they can come after your code. If you put the // at the front, like this. // draw cats 10. Nothing will happen. Chrome sees the whole line as a comment, even if it's JavaScript. Once you start reading JavaScript code out in the wild world, you'll also see comments that look like this. // Draw as many cats as you want. // This is a different style of commenting, which is typically used for comments that are longer than one line. But it does the same thing. Everything between the / and the / is a comment that the computer won't run. In this chapter, you learn a bit about what JavaScript is and what it can be used for. You also learned how to run JavaScript using the Google Chrome browser and tried out a sample program. All of the code examples in this book, unless I say otherwise, can and should be used in Chrome's JavaScript console. Don't just read the code, try typing things out. It's the only way to learn to program. In the next chapter, you'll start learning the fundamentals of JavaScript, beginning with the 3 basic types of information you can work with: numbers, strings, and booleans. Programming is all about manipulating data, but what is data? Data is information that we store in our computer programs. For example, your name is a piece of data, and so is your age. The color of your hair, how many siblings you have, where you live, whether you're male or female, these things are all data. In JavaScript, there are 3 basic types of data: numbers, strings, and booleans. Numbers are used for representing, well, numbers. For example, your age can be represented as a number, and so can your height. Numbers in JavaScript look like this. 5. Strings are used to represent text. Your name can be represented as a string in JavaScript, as can your email address. Strings look like this. Hi, I'm a string. Booleans are values that can be true or false. For example, a Boolean value about you would be whether you wear glasses. Another could be whether you like broccoli. A Boolean looks like this. True. There are different ways to work with each data type. For example, you can multiply 2 numbers, but you can't multiply 2 strings. With a string, you can ask for the first 5 characters. With booleans, you can check to see whether 2 values are both true. The following code example illustrates each of these possible operations. 99,123. 12,177. This is a long string. /0, 4. This. True, false. False. All data in JavaScript is just a combination of these types of data. In this chapter, we'll look at each type in turn and learn different ways to work with each type. Note: you may have noticed that all of these commands end with a semicolon. Semicolons mark the end of a particular JavaScript command or instruction, also called a statement, sort of like the period at the end of a sentence. JavaScript lets you perform basic mathematical operations like addition, subtraction, multiplication, and division. To make these calculations, we use the symbols and /, which are called operators. You can use the JavaScript console just like a calculator. We've already seen one example, adding together 3 and 4. Let's try something harder. What's 12,345 plus 56,789? 12,345, 56,789. 69,134. That's not so easy to work out in your head, but JavaScript calculated it in no time. You can add multiple numbers with multiple plus signs. 22, 33, 44. 99. JavaScript can also do subtraction. 1,000 to 17. 983 and multiplication, using an asterisk. 123 456. 56,088 and division, using a forward slash. 12,345 forward slash 250. 49.38. You can also combine these simple operations to make something more complex, like this. 1,234 57 3 to 31 forward slash 4. 1,397.25. Here it gets a bit tricky, because the result of this calculation, the answer will depend on the order that JavaScript does each operation. In math, the rule is that multiplication and division always take place before addition and subtraction, and JavaScript follows this rule as well. Figure 2 to 1. T. The order of operations: multiplication, division, addition, subtraction. Figure 2 to 1 shows the order JavaScript would follow. B. RST, JavaScript multiplies 57.3 and gets 171. Shown in red. Then it divides 31 forward slash 4 to get 7.75. Shown in blue. NE. XT it adds 1,234 171 to get 8 forward slash 13. 11. That can't be right. You can't give each sibling 11 candies when you've only got 8. The problem is that JavaScript does division before addition, so it divides 8 by 1, which equals 8, and then adds 3 to that, giving you 11. To fix this and make JavaScript do the addition first, we can use parentheses. 8 forward slash 13. 2. That's more like it. 2 candies to each of your siblings. The parentheses force JavaScript to add 1 and 3 before dividing 8 by 4. Try it out. Let's say your friend is trying to use JavaScript to work out how many balloons to buy. She's throwing a party and wants everyone to have 2 balloons to blow up. There were originally 15 people coming, but then she invited 9 more. She tries the following code. 15 9 2. 33, but that doesn't seem right. The problem is that the multiplication is happening before the addition. How would you add parentheses to make sure that JavaScript does the addition first? How many balloons does your friend really need? JavaScript lets you give names to values using variables. You can think of a variable as a box that you can fit one thing in. If you put something else in it, the first thing goes away. To create a new variable, use the keyword block, followed by the name of the variable. A keyword is a word that has special meaning in JavaScript. In this case, when we type block, JavaScript knows that we are about to enter the name of a new variable. For example, here's how you'd make a new variable called Nick. Var Nick. Undefined. We've created a new variable called Nick. The console spits out undefined in response. But this isn't an error. That's just what JavaScript does whenever a command doesn't return a value. What's a return value? Well, for example, when you type 12,345 56,789, the console returns the value 69,134. Creating a variable in JavaScript doesn't return a value, so the interpreter prints undefined. To give the variable a value, use the equal sign. Bar age equals 12. Undefined setting a value is called assignment. We are assigning the value 12 to the variable age. Again, undefined is printed, because we're creating another new variable. In the rest of my examples, I won't show the output when it's undefined. The variable age is now in our interpreter and set to the value 12. That means that if you type age on its own, the interpreter will show you its value. Age 12 cool. The value of the variable isn't set in stone, though they are called variables because they can vary, and if you want to update it, just use equals again. Age equals 13. 13 this time I didn't use the bar keyword, because the variable age already exists. You need to use bar only when you want to create a variable, not when you want to change the value of a variable. Notice also, because we're not creating a new variable, the value 13 is returned from the assignment and printed on the next line. This slightly more complex example solves the candies problem from earlier, without parentheses. Bar number of siblings equals 1, 3. Bar number of candies equals 8. Number of candies / number of siblings. First we create a variable called number of siblings and assign it the value of 1, 3. Which JavaScript works out to be 4. Then we create the variable number of candies and assign 8 to it. Finally, we write number of candies / number of siblings. Because number of candies is 8 and number of siblings is 4, JavaScript works out 8 / 4 and gives us 2. Capitalization wrong. The JavaScript interpreter won't know what you mean. For example, if you accidentally used a lowercase c in number of candies, you'd get an error. Number of candies / number of siblings. Reference error number of candies is not defined. Unfortunately, JavaScript will only do exactly what you ask it to do. If you misspell a variable name, JavaScript has no idea what you mean, and it will display an error message. Another tricky thing about variable names in JavaScript is that they can contain spaces, which means they can be difficult to read. I could have named my variable number of candies with no capital letters, which makes it even harder to read because it's not clear where the words end. Is this variable number of candies or number of candies? Without the capital letters, it's hard to tell. One common way to get around this is to start each word with a capital letter as in number of candies. This convention is called camel case because it supposedly looks like the humps on a camel. The standard practice is to have variables start with a lowercase letter, so it's common to capitalize each word except for the first one, like this number of candies. They'll follow this version of the camel case convention throughout this book, but you're free to do whatever you want. Find out how many seconds there are in a year and how many seconds old you are. Let's start by finding the number of seconds in an hour. Seconds in an hour. First we create two new variables called seconds in an minute and minutes in an hour and make them both 60 because, as we know, there are 60 seconds in a minute and 60 minutes in an hour. Then we create a variable called seconds in an hour and set its value to the result of multiplying seconds in an minute and minutes in an hour. We enter seconds in an hour, which is like saying, tell me the value of seconds in an hour right now. JavaScript then gives you the answer. It's 3600. Bar seconds in an minute equals 60. Bar minutes in an hour equals 60. Bar seconds and power equals seconds and minutes and power. Seconds and power. 3,600 seconds in a day. Now we create a variable called hours in a day and set it to 24. Next we create the variable seconds in a day and set it equal to seconds in an hour multiplied by hours in a day. When we ask for the value seconds in a day at, we get 86,400, which is the number of seconds in a day. Bar hours in a day equals 24. Bar seconds in a day equals seconds in an hour hours in a day. Seconds in a day. 86,400. Seconds in a year. Finally, we create the variables days in a year and seconds in a year. The days in a year variable is assigned the value 365. And the variable seconds in a year is assigned the value of seconds in a day multiplied by days in a year. Finally, we ask for the value of seconds in a year, which is 3153600. More than 31 million. Bar days in a year equals 365. Bar seconds in a year equals seconds in a day days in a year. Seconds in a year. 3153600. 914544000 to figure out